Oh, never mind.
Hi Molly, we're in physics now, and this is the problem that we're working on the back of our comp books. So go ahead, everyone, and get to that spot. Jonathan, can you join us real quick? We left a permanent stain on the carpet, so we left our mark, Jonathan. Aaron, why didn't you catch it? You were sitting right there. I thought of that in the middle of the night. Why didn't Aaron catch it? All right, let's look at how to do this. It turns out a sketch is always helpful. So here's my vector. It's at 38 degrees, and it's 6.8 long. You remember that much, what the numbers refer to? The angle from the positive x-axis goes around 38. That's probably a little more than 38. 45 is right in the middle, so mine's a little generous. So sketch it, and then we are looking for every diagonal vector can be divided into a horizontal, that's what we call the x part, and then the vertical is what we call the y part. So it just becomes a trig problem, and you'll recall that sine and cosine are the ones that come out to play in this instance. So the question is, which is which? Somebody help us. Is sine going to be the y or is sine the x? Alex?
X is cosine, y is sine.
Pardon?
X is cosine and y
Right,
is sine.
x is cosine. Do you have a way that you remember that?
No.
Oh, okay.
It's just there.
It was right there, so available to your memory. I was wondering if you had a method. I got to think of one of those little tricky sayings. All right, so it's always magnitude, cosine, 38. Make sure you're in degrees. Some of you who are floating around in other math classes might be in radians. So 6.8 cosine 38 will give you the x value, the x component, and 6.8 sine 38 will give you the y. So you need to recall these things so you can do well. Anyone got all results all the way through? Hannah, what'd you get for the x?
I got 5.4.
Confirmed?
Yep.
Anyone else? Thank you. And Annabella, did you get the y?
Yep.
What?
4.2.
What, 4.2? Confirmed?
Uh-huh.
Okay. So that was our big review question of the day. All right. We're going to turn this off for a little bit. I'm going to hand back some, actually I'll show you yours first. I guess you don't care if everyone sees what you did. I just want to hand back the lab graphs. And I didn't grade them, I just told you what you needed to do to improve your lab graph. So I'll collect them on Monday for real and give them a grade. Recall that every graph needs a title at the top. So this could be the stretch of a string, the stretch of a spring, or you could say, I know how we titled them. We used whatever was on the vertical versus whatever's on the horizontal. So it was spring stretch versus weight graph. You don't have to use the word graph, but that needs to be a title up there somewhere. And every axis has a title and a unit. Some people just put like newtons down here. And I do need newtons down there, but put weight in newtons. So you need to label each axis for what it is and the unit that it's displaying.
Yeah.
Some people just put a number for slope. Show me the triangle that you use to get that number with a value here and a value here. So I put on there what I wanted you to improve on. So Molly, I'll just show you yours when you come in on Monday. So you can shut that down for a little bit. We'll be back. All right.